Today we're going to find the first derivative, but we have to use the first principle. And this is always a question that's in every exam paper. It's always 5 or 6 marks, and you have to get the first derivative, but you have to use the first principle. So let's just talk about this let's just talk about first derivative. What are we actually doing when we get the first derivative? In theory, I can see that this is a parabola. So whenever I derive, I'll find a gradient, and this gradient will be valid on this whole function. So wherever I've got a point on that function, that would be the gradient. And just it all depends on what the x value is, which I'm going to sub into my derivative, and that will be the exact gradient at that point. So what I need is I need to find the derivative, which is the gradient, and if I've got an x value and I sub it into that point, I will get the gradient at that specific point. Now, and you know the first principle of by heart by now. I've got a feeling that this you've done quite a few times. Now remember, as soon as I've got f of x, I must first find f of x plus h. So wherever there's an x, and there's one and there's one, I have to replace it with f of x plus h. Remember that I need to square this, so let's just highlight this. So in fact, this is my f of x. So I've just replaced every x with an x plus h, and again plus 8, and the x I'm going to replace with an x of x plus h. Okay, so every x has been replaced with an x plus h. Okay, now we can write down our formula, and the formula is quite easy, and I think you know this off by heart. It's the derivative, but there's a limit as h approaches 0. Okay, and then the formula is f of x plus h, and then you subtract the original function all on h. Okay, so let's just make this a bit neater. Okay, so now I'm going to just sub these two functions into my formula. There's a limit as h approaches 0, and you have to keep on writing this limit. And just remember, these are marks. You want to keep these marks. F of x plus h is this value over there. So it's 4x plus h squared plus 8x plus h. And then I'm subtracting my function, my original function, which is 4x squared plus 8x. Remember to put the original function that you are subtracting into a bracket, because it's a binomial and you have to put a binomial in the bracket. And then we're just going to simplify. Okay, I'm going to keep my 4 on the outside as long as possible. I'm just going to, let me just rewrite this bracket twice. No, I'm not, you have to write it twice. Yeah, let's just do it. And we're just going to distribute the 8 into the bracket, plus 8h minus this minus, let's distribute it in, 4x squared minus 8x, and this is all over h. Okay, so let's just further simplify as far as we can, and we're going to keep this h as the limit as h approaches 0, because at the moment we know that h is in theory 0, but we can't make it 0 because otherwise this fraction would be undefined. So let's just simplify this further. So I'm just going to keep my 4 on the outside. I'm just going to FOIL this all in. So it's x squared plus 2xh plus h squared plus 8x plus 8h minus 4x squared minus 8x all over h. Okay, well, let's simplify further. So we're going to keep on simplifying as far as we can. We're going to distribute this 4 into the bracket now. 4x squared plus 8xh plus 4h squared plus 8x plus 8h minus 4x squared minus 8x. Okay, so there's a limit as h approaches 0. And we still have to simplify. Now at this point, after my brackets are all been removed, you'll notice that some of these factors can just cancel out. And the problem is, and the main thing is that every term without an h is supposed to cancel out. Okay, is there something else? Yeah, there's a 4x squared minus 4x squared, so that cancels out. So I'm stuck with 3 terms at the top, so let's just rewrite that. So we've got 8xh plus 4h squared plus the 8h. That's what's left after I've simplified. At this point, after I've simplified, I need to factor. And you know, the important part is if you look at this at the denominator at the top, I can actually take it a 4h. I prefer not to do it. I'll just take out every single time. I'll just factor h out so that h's can cancel out. So I've got 8x left plus 4h plus an 8 all over 8 all over h. And now this and this can cancel out. And now, as soon as it cancels out, I don't have any limits anymore because the h's at the denominator is gone. Now at this point, I'll remove the limits and I'll rewrite my nominator, what's left of it, but I'll replace h with a 0. So this is the only time I'm going to do it. So I've simplified it. I've cancelled my h's out after I've factored, and now I've got a gradient. So this would be my gradient, which I found on my first principle. Now think of this: if I do have a parabola, that my gradient all over every single unit over there, or every single coordinate, will be exactly 8x plus 8. So if I know what this x value is, and I can probably read it off to my graph, let's just make it like this, and this is x is 4. If I sub my x with a 4, in fact I will get the actual gradient of that tangent at that point. So in this case it would be 40. So my gradient would be 40 at that point. But this was not the question. The question was just find the derivative. And we've done it. We've used the first principle. You can always test your answer by just deriving this quickly. So my f of x. So we can just check our answer. F of x was, the original function was 4x squared plus 4x squared plus 8. Was it 8x? Yeah, it was. So how do we derive without the first principle? Quite easy. This multiplies with the coefficient, so it's 8, subtract 1, plus this 1 times multiplies with 8, and we subtract 1. So this is in theory correct. Both our answers are right. So we can actually test our answers. So that was a parabola. So let's take our hyperbola, and we need to derive this. We need to get the first derivative of a hyperbola by using the first principle. Now remember, when I need to use the first principle, I need to find my f of x plus h. So in theory, what we're going to do is we're going to replace every x with an x plus h. So let's do it. 2 over x plus h. Now we can write down our formula. So we're going to find the first derivative as with a limit as h approaches 0. And then our formula, which is f of x plus h minus f of x all over h. Let's just clean this up a bit. Okay, so let's just sub all those functions in. F of x plus h, we know what it is, so it's just make a fraction. I just need to keep this neat as possible because it's a fraction on top of a fraction. That's my f of x plus h minus my f of x. This time it's it's not a binomial, it's only one term, so I don't have to use a bracket. Okay, all over h. So let's just simplify this. Now, as soon as you've got brackets, fractions on fractions, you probably have to go to, you have to probably get the LCM on this. So let's just find the LCM of this top fraction. And what are we going to use? We're going to use everything that's at the bottom at the moment. It's this term and this. That will be my LCM. So it would be the x, and the x plus h would be my LCM. Now I just need to this is my denominator, so I just need to fix my nominators. So the 2 had the x plus h, so it needs the x, and the second term, the 2, had the x, so it needs the x plus h. Okay, let's simplify further. There's a limit as h approaches 0. So let's just simplify the fraction there as far as we can. The 2x minus the minus is just going to distribute into the bracket, so it's minus 2x minus 2h all over my denominator of my fraction, my LCM, and that's all over h. So I can probably simplify this further. You just keep on simplifying as far as you can. Now 2x minus 2x is 0, so there's left minus 2h over my fraction, my denominator of my fraction, which was x plus h, and that's all over h. Okay, now at this point I need to bring this h to the top. Now I'm going to do this. I'm just going to flip it. No? So let's do it. So fraction over fraction is minus 2h over x plus h. We're not going to divide with an h. We're going to multiply with 1 over h. We're just going to sort of flip it. And then from here onwards, I can still go further, get rid of my h at the bottom, which is brilliant. I still got an h here over here, but this time I'm not going to worry about it because it's in a bracket. So that will hide my my 0. Okay, so let's just simplify this. So we've got a limit as h approaches 0 of negative 2 over x, and we're just going to multiply this in plus xh. Now from here it's quite easy. We're going to remove the limit now because we're going to sub h with a 0. Now there is a 0 at the bottom, but that's not going to make my fraction undefined because it's 2 terms at the bottom. So we're going to remove the limit, and we're just going to make sure that we sub 0 in the position of h. So I've got minus 2 over x squared, which is perfect, and that is the right answer. So let's just let's test our answer. So the original function is f of x equals 2 over x, I think. And how do we derive it? Before we derive it, let's get rid of the fraction by moving the x to the top. Now we're going to multiply this with a coefficient, so it's minus 2x. We're going to subtract 1. After you minus your exponent with a coefficient, subtract 1 from your exponent, and then we're just going to move it downwards again. And I can see that both these answers are fine. You don't have to show this test. We just do the test to make sure that you do understand. You make sure that your answer is correct. So these are the marks that you do need. So you just need to work on the parabola. If you've got a parabola and you've got a hyperbola, can you derive it by using the first principle? Always make sure that you got your formula spot on. That formula needs to be spot on, and you need to make sure that your f of x plus h is absolutely right. So every x gets replaced with an x plus h.